22. Part 2 of the video, if there even is a part 1. Number 22. I can call names for this. This should be the straightforward stuff, I think. So let's put some people on the spot here. Bella, tell me one of the transformations on number 22.
Right 4.
Right 4. Kendall, tell me another transformation to 22. Down 3. And Dimitri, what's that 1/2 doing out front? What does that do to the graph? I mean, you can show me with your hands if you don't use the words. Like, what's the 1/2 do out front? A negative would flip it. The multiplier does one of these things to it. But if it's smaller than 1, it's going to squish it. So a vertical squish or compression would be the fancier word. Although this one doesn't even ask for the words, it just says graph it. So right 4, down 3. There's our starting point. And the slope, kind of in quotes because it's not really a slope, up 1 over 2. Certainly acts like a slope, certainly to the right anyway. And again, take the 2 seconds it takes to make sure that you did what you said you were going to do. Again, no mistakes are usually made that direction. The mistakes are made going from what you write to what you graph, which I can't figure out how that happens. Because like you understood everything and then somehow it didn't get over there. So let's just double check here. Right 4, down 3, vertical squish. All right, I feel good about 22. Yeah, and then we're on to more where I can pull people. Ava can tell us number 2. Andrew can get 6. And Keegan can get number 10 when we get there. So, this is to your point. Like, you don't have to graph these, you just have to explain what the transformation is. So, Ava, what transformations have happened to number 2?
A vertical stretch by 3. And down 4.
And down 4. Now, that one's absolute value, so you absolutely could graph that one. We wouldn't expect you to graph number 6, Andrew, but I would expect you to be able to tell me what transformations have taken place.
A reflection over the y-axis.
Okay. Hold on a second. Reflection over y-axis. What's another way to phrase that? Horizontal flip. You can phrase it either way. Like, what you said is technically correct. Some people just think of it as a horizontal flip. So I'm going to write both because either would be acceptable. Okay, and then continue. What was the other one?
And then go down 4.
And then down 4. What would a reflection or a horizontal flip do to a parabola? Nothing. And that kind of makes sense because what happens when you square negative x? What do you get? You would just get x squared. So it makes sense that reflection doesn't really do anything because when you square a negative, it just becomes positive. And so technically, yes, it's a reflection, but practically, if and when you drew that graph, you wouldn't be able to tell that you reflected it or not. Keegan, how about number 10? What changes have happened here? Vertical flip. Vertical stretch. And down 4. Very nice. And then that last one, reciprocal function. Okay, so that's 1 over x. I haven't done much with that. So we won't have to graph it, but we will need to be able to do those transformations. Reflection over the x-axis. So that's a vertical, that's an up and down. So that would be a negative, or like a negative out front. horizontal translation right 7, so that would be x minus 7. Vertical translation up 3. Plus 3. So there's my answer. Y equals negative 1 over x minus 7 plus 3. So the flip, the right, and the up. Yes. Just a side note on that, when it says write an equation, you've got to have y equal something. If all you put is sort of the right-hand side of the equation, I'm going to take off a point or two. And maybe that seems harsh because you did all the hard stuff right, but that's not an equation unless you have y equals on there.